Hi friends, in today's video we are going to see how to read a plumbing drawing for a high-rise building project. I particularly selected this high-rise building because this is a luxury project. This is a luxury high-rise building project. It has some special requirement. That requirement you cannot see in other normal project, normal residential and commercial project. That's the reason I particularly selected this project for the today video. Additionally, we will see lots of important rules related to the site installation based on the International Plumbing Codes (IPC), and also some additional rules we will discuss about from Middle East requirement like Qatar requirement, UAE requirement, Saudi requirement. So all these things we will discuss in one video. So let's start the video. Whenever you start reading any drawing for the any project, first you have to see the single line diagram of the project, because the single line diagram will give you very clear picture about what is there in the project. So after that you can go to the layout, you can go to the notes and plenty of things. So first in our project we have two basement like you see here. At this point we have second basement, first basement, and ground floor, first floor, and till we have at this level, that is the sixth floor, then we have the roof floor. So in our project we have the water supply fire pump, water supply room, like you can see here, domestic water tank, that is the plumbing water tank, so which is located in the first basement. In the ground floor we have the fire water tank, and in the first basement in our case, now we have the water supply pump room is there. So here this is called as a transfer pump, because it transfer the water from the low level to the high level. So first in our case where the water comes, like we can see this point, 50 mm CWP is the cold water pipe from city network. So from the municipality network we are getting the main water. So in this main water we have the water meter to measure the water amount of water level flowing into the system. So the main water meter is located here. So the dia is mentioned here 48 mm because that is related to the copper pipe. I'll show you the detail also. This 50 mm dia is an underground pipe coming from the municipality, that is the HDP line, high density polyethylene or medium density polyethylene line. So that is the reason the dia seems different. So that is the logic. So I'll show you that one also. So the next one, after coming to this level, we can see there are two difference. One is going down, one is going straight, and straight pipe which is the 28 mm fire water line, and the down one which is going to the water supply tank, that is the 50 mm cold water pipe at a high level for the domestic water makeup line. So coming to this side, we have the float wall. For both the arrangement we have given the float wall, and after that this side you can see we have first the transfer pump. So the transfer the water to the roof level. So in our case we have 75 mm water pipeline. Like you see, this is mentioned that PPR, polypropylene random pipeline is mentioned at this point. Normally in the Middle East, for all the above ground application, I mean for the water supply system, we normally use the PPR, polypropylene random copolymer pipes. And coming to the underground, for all the application for the water supply, we mostly use HDP pipeline, high density polyethylene pipeline. And this line which is going to the roof level. So in the roof level, you can see here we have the water tank here, GRP water tank. So makeup here they have mentioned the capacity. 35 meter cube water tank is located at this level, and after this one we have the another pump that is called as a booster pump. This booster pump is used to provide the water to different sanitary fixtures located in the apartments. So from here you can see two lines. So the first line you can see at this point, which is not going through the pump, which is directly coming from this level, that is called as a gravity line, and after the pump the line will be pressurized line, that is called as a forced line. So there are two lines which is coming from here. One is with booster pump, another one is without passing through the booster pump. So now both line passing down. So in our case what we have done, the top three floor, I mean from this floor to this floor, we cannot see that much gravity pressure, because the line, for example, if I use this gravity line to top three floor, there will not be any pressure. That is the reason I am using the gravity pipeline only for the low levels. For example, you can see this gravity pipe I am using for this level, this level, this level, and this level. So that means only for the first three floor I am using the booster pump pressurized line. So you can see this line, 50 mm cold water pipe, which is connecting with this booster pump pressurized line. So which is at this point, and we have to provide one common gate wall. After that, you can see there are multiple meters I have shown here. They have mentioned 8 number 22 mm water meter. As I told you, this 22 mm is a copper pipe, because inside water meter there will be a copper pipe. I'll show you the detail also. Then one number for the public utility. That means in this project we have the garbage chute. Garbage chute we have. So we need one separate water meter for the garbage chute also. That also I will show you for this one. You can see here all this individual meter. From here one by one supply connection is going to flat number 1, 2, 3, 4, 5, 6, 7, and one more line you can see it is coming here, which is for the public utility. Public utility mean we have the swimming pool, we have the gym in the roof. So for that we have one connection here, and another connection which is going to the garbage room. Garbage room, you know, that waste collection room. So there we need the hose bib for the cleaning. So there is a separate connection for each floor. From this line you can see here, for each floor it will go to clean the garbage room at a different levels. So we have provided the hose bib at a different levels here. So similarly you can see the same line I have continued down, and this 2 level also I followed the same concept, because there are different apartments are there. Each apartment we have the separate water meters are there. So this will serve to different apartments. So these 3 floors we are using gravity pipe, because here the gravity pressure we are using the pressurized booster pump, and because their gravity pressure is very low. And this line you can see here, cold water pipe, so which is going down. So this is the gravity line. So this line is supplying the water to all the bottom floors. Like you see here, this 4th floor which is supplied by the gravity line. So this is the basic concept of our project. Let's see one by one the layout drawings. The first thing we want to see here, the pump which we used for the project. So in the second basement we are using one pump that is called as a lifting pump or transfer pump. So this pump which is serving to which is supplying the water from base to the roof area. So this capacity is 80 GPM and 150 feet pump we are using, one duty and one standby. Coming to the next one which is at the roof floor. So that one just now we saw in the drawing also. So in the roof level also we have one more pump that is called as a booster pump, which is at this is what they have mentioned here. So this roof floor pump, which is called as a booster pump. So this is supplying to the low level, because high level which is supplying to the high level, because the low level we have the gravity system, so no need of pumps. So this is 80 GPM and 45 feet we need for this one. And here we have the setup of like 2 duty and 1 standby pump. And the third one is the irrigation pump, which we are not going to discuss at this level. When it comes to irrigation system drawings, we will see very detail about irrigation piping and drip line and all together. First in the drawing, they have given the minimum pipe size for a sanitary fixer. For example, water closet, they have mentioned cold water pipe is 1/2 inch. Hot water is not required for water closet. Coming to lavatory or wash basin, we will call it. For example, that one they have given water supply, cold water 1/2 inch and hot water also 1/2 inch or 20 mm. And coming to that is a janitary sink. So again the same step they have given, same sizes. And KS means a kitchen sink. So kitchen sink also same pipe sizes they have given. So going down, there are different materials we need to understand for the usage. For example, all cold water supply pipes inside the toilet and corridors above false ceiling are embedded in the wall. So these pipes will be PPR, polypropylene, and PN16 rating should be there. And all cold, this means the first point they are telling that wherever the pipe which is passing above the false ceiling, and also in the toilet area we have the wall will be there, na? So the wall, the pipe will be embedded. For example, this is the slab, this is the ceiling, so the pipe will come like this, then it will go through the wall and here it will come out. So here we have the, for example, here we have one wash basin. So this full pipe they are telling polypropylene PPR for the cold water application. Coming to the cold water pipes inside the duct, for example, you have the mechanical shaft, which we'll call shaft or duct. So that area we have to use the HDP pipe, and this is also same pressure rating, the PN16 rating should be there. And all cold water, hot water return pipe, if you have hot water return pipe also, because if you have the central system. But in our project we don't have the central system, we have the individual water heater. So if you have this like a cold water, hot water return pipes at the roof are exposed to sun radiation, it shall be insulated PPR. So the same PPR pipe again you have to provide the insulation over the pipe. So after that, all suspended water pipe at basement and underground shall be HTP. So in the basement pipe and suspended that area pipe should be HTP should be provided, and pump room pipe shall be ductile iron or HTP. Okay, some project they will ask for UPVC also only inside the pump room, because that is the exposed area. And pipes also, some pipes at low level, some pipes at high level will be there. So some project they will ask for UPVC also. This project they have asked for HTP or ductile iron. Ductile iron is a bit expensive, so we normally use the HTP for this area. And all hot water supply riser inside duct shall be insulated PPR. First of all, when it comes to hot water, we have to provide the insulation for the hot water pipes. Then hot water supply and hot water return, all pipes shall be PPR insulated one. So this should be followed. Then they have mentioned like puddle flanges for all pipes penetrating into the tank. For example, if we have the RCC concrete tank, the pipe is coming like this and which is going inside. For example, this is the floor to wall, this is the water level. So this penetration for the RCC tank, I am telling you have to provide the puddle flange. Similarly for the suction side, here you have to provide the puddle flange. Here you have the pump. So suction side, here you have to provide the puddle flange. So this requirement is mainly for the RCC tank. When come to GRP tank, normally we don't provide the puddle flange. I will tell you what is the reason for that one also. And coming to the next one, all visible piping and exposed water supply piping in the roof shall be cladded. So you have to provide the cladding, that is the aluminium. So aluminium with a minimum 0.9 mm thickness. So this is very important because some project they will ask different kind of thickness like a 0.6, 0.7, 0.9 mm. So this thickness you have to verify before you proceed with the material procurement and material submittal. And you during the tendering time also you have to verify the thickness when you pricing. So this item is very important. They have mentioned here 0.9 mm thickness. So pipe will be there, again insulation will be there. After the insulation you have to provide the 0.9 mm thickness aluminium. And here the important thing is water hammer arrestor has to be provided as per specification. So in order to avoid the sanitary fixture damage, because when you suddenly close one sanitary fixture, that vibration will be transferred to other sanitary fixture also. To avoid that type of thing, we normally provide the water hammer arrestor. I will tell you where to provide in this drawing, and there are some special requirement also there, that also I will explain in this drawing. Then provide automatic air vent at top of the riser. So each riser must have the automatic air vent. So we have to provide that one. So this is the overall second basement. So in the second basement, we saw the riser diagram. It was only hose bib. So we will see where it is. So first we have the domestic water tank in the second basement. From here we have the domestic water pump room. So here you can see this suction line which is taken from the domestic water tank. This suction line. And here we have the discharge line. So domestic water tank, as I told you earlier, if you are taking the suction line or any line from the domestic water tank, you have to provide the puddle flanges in the wall. So for this line RCC tank, RCC domestic water tank, so you have to provide the puddle flange in the wall. And this line you can see 50 mm cold water pipe coming to fill the domestic water tank. So this line is coming from the ground floor and which is coming to fill the tank. So this is your floor to wall, and here also in the wall you have to provide the puddle flange. So this is your discharge line, and this discharge line based on the riser diagram we saw that it will go to the roof to fill the roof tank. So this is a 75 mm cold water pipe at a high level PPR pipe which is going to the roof. Here you can see to fill the roof tank. So all this pipe material we saw that it was PPR pipes, but as per specification the pipe material which is inside the pump room is ductile iron or HDPE. So we used HDPE for this project. So after that, for the car parking, we need the hose bib at different location for the cleaning area. So for example, here you can see 20 mm cold water pipe from above, that is a PPR pipe to hose bib. So from above some pipe is coming 20 mm and which is going like this and which is going like this, and here we have the hose bib. So similarly like this arrangement, we have the hose bib at three different area, the basement, and here also you can see another hose bib will be there, same like what we saw, and here also you can see another hose bib. So three different area they have covered like this, 1, 2 and 3 for the cleaning area, cleaning purpose. And this pipeline which is coming from the first, this is the first basement drawing, the same like what we saw in the second basement. Here also we need the hose bib area. So here you can see from where the drawing the line is coming. So 32 mm cold water line from above. So from above there is one line is coming, and this line is distributed to different areas, like you can see the line is coming like this, and from here it is going up and going down, and here we are going like this, and one line has to go to downside to the second basement and one line has to serve to the first basement. So that is the reason from here the line is coming, and here you can see what they have mentioned, 20 cold water pipe to below to hose pipe. So that means this from the first basement the line is going to the second basement also. Here from this line one line is going to bottom, and the same line we have taken the branch, and here we have the hose pipe. So like this concept we have three hose pipe at three different locations. So from here the line supply line, and here we have the hose pipe, here we have another hose pipe, and also same line in the top we have another hose. So there are three hose pipe here. In our ISA diagram you can see this is the second basement, we have three hose beam, first basement three hose beam. This three hose beam line supply line is coming from top side. So if you see this line, this line, okay, here is going up, so this line is supplied from the roof level. For example, if you go to the top of the roof, so this line is coming like this. So this 50 cold water pipe for PPR for public utility. Public utility means the public areas. So this is going to the swimming pool, this is going to the gym, this is going to the each level of garbage room, because garbage room is a public area. That water consumption we cannot add in the tenant water. So that's why this garbage room we have a separate water meter, and in that water meter itself we have connected the hose pipe. So this is in the public area. In our project, first floor to third floor has a typical layout. So starting from the riser, for example, here you can see 75 cold water gravity line to below to serve to third floor, second floor, first floor, and the gravity floors. So here from this 75 line, you can see this line is supplying to all the water meter for the different apartments. I will take one apartment branch line. For example, this line. You can see one branch is supplying to the bottom. Here we have the wash basin and water closet. So the toilet detail drawing, this will be developed like supply to wash basin and supply to water closet separately. So this is the main branch shown here. And moving further from here, it is another branch is going down, which is for the laundry area. So we have the washing machine here. And moving up, we have one line supplying to water heater, and moving up again you can see in the pantry we have the kitchen sink here. So here we have one supply line for the kitchen sink, and again further this line is going to the main bathroom. The main bathroom we have the wash basin, we have the water closet, we have the bathtub. So for all this line we have supplied one line. So similarly for another apartment you can take this line also, the same concept, which is going down, and which is the line is coming like this. And here you can see one line is for the wash basin water closet branch, one line is for the laundry, and this is going down, one line is supplied to water heater, and this line same like you can see pantry, and finally this is for the bathtub. And from the water heater this line is coming back with the heater line. This line is like a hot water line with the insulation. Cold water line no need insulation here, but hot water line here, because after the heater we need the full insulation line here. And one line is supplied to kitchen sink, the hot water line, one line is supplied to wash basin and bathtub also. This will be supplied from the hot water line. So again from here this line is going further, and which is going to this bathroom. Here we have the wash basin. So this is the hot water supply line. There are some important rules we need to understand when it comes to the installation. We will see one by one what is that. The first thing, like the all pipe dimension in the drawing are internal or external. This is very important because this will make most of the installation mistake. So here for example you can see at this point they have mentioned like a 75 cold water return pipe. So this one we need to know whether it is a internal dia or outer dia. So in all the drawing legends in the first in the notes page they will clearly mention all pipe dimensions shown here is the internal dia or external dia. So based on that one only we need to proceed, because here also you can see 22 water meter pipeline they have given. So this line again 75 cold water pipe to fill the roof tank. So are these pipe dimensions internal or external, that we have to verify in the first step. The next important thing is verify the underground and above ground pipe material. This is already we discussed because I showed you the PPR pipe we are using only for the above ground, HTP pipe we are using for the underground, and inside the pump room also we are using HTP pipes. And in this project particularly they told us to follow PPR pipe only for the above ground and HTP pipe only for the inside pump room. But HTP pipe still it is yeah, we can mostly we are using for the underground pipeline, and EPC also we can use for the above ground. Some project they will tell us to use the PEX pipe also, so we have to make sure that what is the underground and above ground pipe material. And the very important thing for the luxury project, because this is the luxury project, so here we have in the PPR there are two type of PPRs are there. One is the normal PPR pipe, another is the PPR CT pipe. This PPR CT pipe is we are normally using where there is a project is a luxury project and client wants the noise resistance. So to avoid the noise, we are instead of using the PPR pipe, we will use the PPR CT pipe, which is very expensive compared with the PPR pipe. So the difference like you see here, PPR CT is a newer generation pipe. PPR CT material has approximately 25% higher stress capability and a 25% higher pressure rating than PPR pipes for the same wall thickness at it same at a given temperature. That means they are telling 25% higher pressure rating it can withstand and 25% higher stress capability it has. It has some special layers, so that's the reason the PPS city pipe is used where there is a noise is a concern. So for that's why if you are going with a luxury project, you have to verify the PPR or PPS city is allowed for the project. And the next important thing is the heater in the project specification mentioned as horizontal heater or vertical heater, because you know that normally we have two type of heater in the project, like horizontal vertical heater will be installed like this and horizontal heater. So the issue what normally happens to each project in the project specification they will mention like I need vertical heater like that. But for example, this is your section drawing, this is your ceiling drawing, and if you need vertical water heater, if you want to install the vertical water heater here, you have to make sure that the depth between I mean the clearance between the ceiling and the slab is sufficient to accommodate this vertical water heater here, because in the project specification they will simply mention I need vertical water heater. And if you bring the vertical water heater, if you don't have the space in the toilet bathroom to accommodate the vertical water heater, then it will be wasted the big amount. That's why you have to verify the clearance between the ceiling and slab, the vertical water heater you can install or not. Otherwise you have to go with the horizontal water heater for the installation. This one you have to verify the very initial stage to avoid the material issue and everything. The next important thing is the cold water chiller, cold water pipe insulation. For example, if you see the roof, we don't have any normally in the case of in the Middle East, in the summer time the temperature will be very high. So that's the reason nowadays most of the project they recommend to add the cold water chiller also. Same like our chilled water plate heat exchanger, and in the cold water system also we will have the cold water chiller. So here we have one circulation pump. It will go to and like it will be like this, and from here we have the connection to the building. So in our project we don't have this cold water plate heat exchanger, or you can say cold water chiller. But if you most of the projects in Middle East they are recommending to add the cold water, because in the summer the temperature is reaching very high like 46 48, that much high amount of water temperature we cannot use for the like wash basin and this thing. So that's the reason nowadays these projects, most of the projects are coming with the cold water plate heat exchanger. So if you have cold water plate heat exchanger, then you have to provide all the supply line. For example, in our project what we have, you can see this line 75 cold water line which is coming from the bottom to fill the tank. So this is line coming from the bottom. Now this is the GRP tank, and in the suction line we have this booster pump. So this is there are two line, one is passing like this is the gravity line which is going down, this is the gravity line 75 and the another line which is coming through the booster pump which is coming like this going down. So this is supplying to only top floors only, like sixth, fifth and fourth floor by the booster pump line, and bottom line as we discussed earlier, this is supplied by the gravity line. So in our case there is no plate heat exchanger, there is no chilled water water supply exchanger here. And if you have, what you have to do, you have to provide the insulation same like you provided for the hot water, you have to provide the insulation for the cold water line also. So this is bit expensive, so you have to take care this one. And the next very important thing is the water hammer arrestor for hot water line. So this is water hammer arrestor. When it comes to water hammer arrestor, you have to verify your project specification needs like a branch type water material, water hammer arrestor, or stainless steel you need, or you need copper, or what type of material you need for the water hammer arrestor. So normally this water hammer arrestor, the main purpose, like you see here, water hammer arrestors are used to absorb the shock when the water flowing in the piping system suddenly stops due to the fast closing of shut-off valve and dishwasher and everything. So they mention like if you have a toilet here and you have the isolation valve which is supplying to, we have the pipeline which is supplying to different fixer like a wash basin, a water closet and beaded and bathtub everything. So here it's sudden you are using this bathtub, suddenly you close this one, mean this water will go back with high pressure, it will hit the all the sanitary fixer, so it will make the absorb the shock. That means what will happen, the sanitary fixer will damage after some time. To avoid this one, we are providing the water hammer arrestor before the last fixer. For example, this bathtub is the last fixer for this toilet, so before the bathtub here you have to provide the water hammer arrestor, so the shock issue will not go to all the sanitary fixer. When it comes to water hammer arrestor, we normally do a common mistake that I have explained here. So for example, in our case, what happened here, you can see the supply line. So this supply line which is coming from here, sorry, the supply line which is coming from here and which is supplying to this water heater, and which is going to kitchen sink, and which is going to the bathtub, as well as it will go to the wash basin area and water closet. So here normally what we'll do, before the wash basin we will provide one water hammer arrestor, so it will absorb the shock before it goes to all other fixer. When it comes to hot water, there the mistake is happening. So normally here you see this the line is going to the heater, and from heater the line is coming out, and the line is going like this. So this line will go to, you can see here, one line will go to kitchen sink, one line will go to bathtub, and one line will go to the wash basin. So here also before the last fixer, this wash basin is the last fixer. Before the last fixer, before the wash basin, we have to provide the water hammer arrestor. That is okay. But sometimes just assume that we have only one pantry here. Okay, so there is no toilet, nothing is connected. So for this pantry, let's assume that we have only one kitchen sink for this pantry, and only for this kitchen sink we have the water heater. So this time what happens, supply line will go to the water heater and return line will come, which will supply only to the kitchen sink. So this time we don't need water hammer arrestor, because only one water heater which is supplying to only one kitchen sink. So normally in the drawing always they will mention water hammer arrestor has to be provided for supply and return line. But if we have this type of individual arrangement, we have only one fixer, so there is no need of water hammer arrestor. So we can save the money if you understand the concept very properly. But if you have multiple fixer, then you have to provide the water hammer arrestor. And the next important rule here is the roof tank. You have to verify whether it is polyethylene tank or insulated GRP tank. This is important. Insulated GRP tank or non-insulated GRP tank. So let's go to our drawing. So here you can see we have the roof GRP tank located at this point. So this is the filling line and this is the supply line which is going to the bottom floors. So this tank, you can see this word shaded from sunlight. So if you are providing as per the Qatar civil defense, this rule is very important and properly highlighted in Qatar civil defense, Qatar Karama regulations. So what they have mentioned, if you are using properly insulated GRP tank, no need to provide the shaded one. If you are using non-insulated GRP tank, which is not that much expensive compared with insulated GRP tank. So if you are using non-insulated GRP tank, you have to provide the shaded area. Also sometimes you might have seen that most of the project we are using the polyethylene, the PE tank. You can see the black color polyethylene tank. If you are using polyethylene tank, again you have to provide the shaded area. So because the temperature is very high in the Gulf, because of the high temperature the tank will get a break in some days, in some months. So that is the reason this special rule is applicable. And here in our project, we are using non-insulated GRP tank. That's why we are providing the shaded from sunlight, the shaded protection area for the tanks. The next important rule is verify the tie-in point for water supply network and the water meter connection. For example, in our project, you can see that the tie-in connection line, which is mentioned here, I will just highlight here. You can see the 50 mm cold water pipe underground connected from city network. So there is a city line which is going outside, and from the boundary line we are going there, and we are connecting with the city network. So if you see the section drawing, how this is normally done. So this is your in this diagram you can see the existing DI main. So the existing line is ductile iron water connection. From here I am making the connection like this. So I have to use a special fitting called as a gunmetal ferrule. And here if you see, so this is the fitting normally we are using for this tie-in connection. So through this one we will make the hole. This is the existing pipeline will be there, and through this top we will make one hole here, and this fitting will be fitted over the existing pipeline, and from this line we will, through this whole arrangement we will take the connection. This is to the building. So like you can see here, so the hole will be connected into the existing line, so the water will come, and from here this line will go to the connection. So here this is the point where we are adding our new pipelines. And you can open or close using this wall adjustment. You can open and close the gunmetal saddle arrangement. And this pipeline will go to the water meter cabinet. For example, you can see this is the MDP pipeline. So medium density polyethylene or high density polyethylene pipeline we can use for the underground water application. And from here this will go to the water meter cabinet. This is the water meter cabinet, and here you can see this pipeline is passing through the GRP duct. So most of the project we are using UPVC sleeve also, because the pipe will not be directly penetrate into the wall, so it will pass through some UPVC sleeve or GRP duct, something like that. And inside the water meter cabinet, first we have the lock wall, stop wall, brass lockable type stop wall, so we can isolate the water connection. After that we have the copper pipe, then we have the water meter, and this all setup you can see in the aluminium meter cabinet. After that this one again, this will go to the water meter means water supply tank. Only before the water meter, like I mentioned here, copper pipe and fitting, and after the water meter there will be some small copper pipe and fitting will be there. After that we will after that it will be a normal plastic material like PPR for the exposed one, for the buried one it will be HTP pipe. So only for small area there will be copper pipe we are using. So that is the reason when I say this side plan in the earlier stage, his 50 mm pipe is the HTP pipe, which is the buried one, which is coming from the existing one. And here 42 mm water meter means is the copper pipe size. That's why its the dia seems very low. 50 to 42 means 42 is the copper pipe size. After that again, after the water meter, which is again coming back with the HTP or PPR based on the above ground or underground. So that's why the pipe size are different. So here it is 50 mm cold water pipe PPR. So that means this is above ground pipe. We are using 50 mm PPR. And this is how the section view of the water meter cabinet clearly looks like. So from bottom we have the pipeline comes, and here we have the union, and here we have the stop wall. After that this small fittings will be copper fittings. So like you see here, copper pipes will be there. So this is the water meter cabinet called as a aluminium service cabinet with a size of 600 by 300 by 200 into 3 mm thickness cabinet. And here we have the electronic water meter. This is normally supplied by the authority. After that we will be having the copper pipe for some small length. After that when it comes to outside we have the different material like plastic material, polypropylene, PPR or HTP material. So this is how the water meter cabinet connection is done. And when it comes to connection with the existing, before we cut the pipeline of existing, there will be high amount of pressure water is passing through the line. So we have to get the permission from the authority before we make the connection with the existing line. What normally we do, there will be one front and back side wall will be there. It can be located far away or somewhere nearer there. We have to verify the existing asphalt drawing to locate the front side isolation wall and back side isolation wall. So we have to get the permit, and we have to close both the walls before we proceed the work with the existing line. After that we have to drain the complete water which is located inside this pipeline. We have to drain the complete water, then only we are allowed to make the proper hole. Then we will make the connection, and we will make the tie-in connection with our services. So before you perform any operation, you have to make sure that your service completely you did the flushing, you did the chemical cleaning, you ensure the pH level are proper, means the water qualities are properly available before you make the connection with the existing line. And the next important thing is the isolation wall, because this isolation wall, if you have the buried connection, you have to install the isolation wall in this way as indicated in the image. So like you see here, the pipeline is coming like this, and here we must have the flange adapter. This is very important. We should provide the flange adapter at near to the isolation wall, like you see here. First the flange adapter will come, then flange adapter directly it is connected with the isolation wall, and other side we have the flange connection. So I will show you one image how this arrangement will come. So here you can see at this image, so like this one. So one side the pipe will come from here, this will connect with this one. Other side we have the flanges, so other side we must have the flanged pipe, so this will go like straight away. So this arrangement will come in this way, one side pipe, one side direct pipe, and one side flanges like this. So this will go to the system. So here in this one we have to prepare one chamber, wall chamber like this. So in the wall chamber we normally provide the puddle flanges in the wall, and the top of the wall chamber you can see at this point, this is the finished level, I mean the road level, this is the finished level or road level. So here we normally have one small surface box, like we can say we need to operate from the top of the road level without going inside. So we normally provide one surface box like this, which is 150 by 150 mm ductile iron surface box, and from here you can open the surface box, you can bring the key, and you can operate from the top without going inside this one, this arrangement. So this arrangement is very famous in the Middle East. We normally provide this type of isolation wall, so we can operate from the top. So the wall itself has the arrangement like this. So from the top you can directly make the key to the connection to the wall, and you can operate the walls. And here another important thing is like you see here, this supply line which is going into the toilet. So this further pipeline is not available so far, but what we have to do, we must provide one isolation wall at least minimum for one toilet. So one toilet minimum one isolation wall must be there. For example, if you are entering into the pantry, means inside the pantry, in the ceiling area we have to provide one isolation wall, because if you want to do any maintenance in the toilet, you can close the isolation wall and you can do the maintenance. And if you are providing isolation wall, for example this is the ceiling area and your pipeline is coming like this, and here you are providing the isolation wall, that means in the ceiling itself you have to provide the access opening. So you have to provide minimum 450 by 450, or it's normally recommended to provide 600 by 600 mm access opening for the isolation wall. So in the future you can do the maintenance using the isolation walls. And here it is our roof pipeline. As I mentioned in the starting of the video, all the roof pipelines, whether it is hot water, cold water, whatever it is, exposed to sun, that means this pipeline must have the insulation. Along with the insulation, we have to provide the aluminum cladding also over the pipeline. In some high end of project, very luxury project like this project, the client asked to provide the aluminum tray cover also. So once we are providing aluminum cladding, again the client wants to provide the aluminum tray cover also, because sometime in our project we have the swimming pool and this arrangement. So the people are walking here and there. So the pipes should not be visible from the visible end. So we want to provide that one. So in this project, we provided the aluminum tray cover for throughout the pipeline like this. So the pipe is not visible from outside. Even the child cannot walk over the pipeline, so it will damage the pipeline. So this is the reason we provided. So these are the high-end specification we will call, which is extra protection. Like as I mentioned, instead of PPR pipe, we provided the PPR CT pipe. That is a very special arrangement. Though the project price was very high, and in the additionally we have provided here the shaded area for the GRP tank. So and this type of special arrangements you have to verify normally for the all the project. So finally, in this project, we discuss about how to perform the tie-in with existing connection by we refer the details. Then we refer the water meter cabinet details. After that, we refer the isolation wall, how the buried isolation wall will be installed in the project. Then we refer to different pipe materials for the underground, above ground, the pipes in the soft area, pipes in the roof area. All together we discuss. Then we discuss about the insulation special concept. Then we discuss about the normal PPR and the PPR CT pipes. Then water heater, whether it's a vertical heater or horizontal heater, how to provide the installation. Then we discuss about the water hammer arrestor. That is one of the important thing, and I told some tricky way we can avoid the water hammer arrestor also. So that is all we discuss, and we have to discuss, and we discuss about the isolation wall. And finally now we are going to discuss about the standard details for the water supply system. And the first one we will see the water heater installation. So when you are installing the horizontal water heater like this is the requirement you have to consider properly. For example, the below the water heater you have to make sure at least 150 mm clearance is available, because normally what happens, the false ceiling has some channels. False ceiling itself has some channels. That channel needs some clearance, like 50 mm, some project 75 mm, it will come like that. So we cannot make minimum clearance of 50 or 75 mm, then it is very difficult to install the water heater. So we have to make sure minimum 150 mm in the bottom available, and coming to the top we have to make sure at least 100 mm clearance is available for making proper supports. Okay, so total 250 mm, 150 mm bottom and 100 mm top, total 250 mm clearance is available for proper installation. And coming to the number of pipelines, the first one you can see cold water inlet, that means the cold water connection is going to the heater, and when coming out it will come like a hot water, so hot water supply pipe is available. And additionally we have one more line like you see here. So this line is called as a temperature and pressure relief line. So this relief line normally we are connecting, we will take line like this, it will go down, it will connect with the nearest flow drain. I mean normally the toilet water heater is installed inside the toilet, so there will be some flow drain. So we will take the line relief line, this is called as a relief line. This one will connect with the nearby flow drain. And this arrangement, what you see here is the multiple water meter we saw in our project. We have multiple water meters supplying to different apartments. So normally how this is done, we have the main riser line. From there we will install the pressure reducing valve, because in the line which is coming from the main booster pump or it's a gravity line has high pressure. So we'll install the pressure reducing valve, a common reducing valve. After that we will have the gate valve, this is the main gate valve. After that this line will go to the individual branches. We will make sure the minimum 200 mm gap is there between center to center line, so for the proper maintenance also. And we will have the lockable valve, lockable gate valve will be there, and we have the water meter and we have the check valve. So after that we have the gate valve will come, then this line will go to the individual water meter or individual apartment connections. And coming to pressure reducing valve, normally it has this type of arrangement. So there will be two pressure gauge, one this side, one this side, and there will be two isolation valve. This is normally open isolation valve here and here, and in between this one we have the pressure reducing valve. So if you want to do any maintenance, you can close these two isolation valve and you can do the maintenance for the pressure reducing valve. And additionally there will be one normally closed valve will be there. So suppose if you are doing any maintenance at this point, you can bypass the valve, bypass the water also. That's the reason we have one bypass valve also. So this is how the PRV station is assembled. And this arrangement for the pipes which is located in the roof, because roof we need the support from the bottom slab. So here we have the concrete slab, and after that we have the concrete base with 150 by 100 mm concrete base. After that we have 100 by 5 mm GI plate will be there over the concrete base, and from here we will provide the threaded rod. And after that there will be split clamp, we can say called like a split clamp. So the split clamp support will be provided. This is for the cold water pipe. Same we can provide for the hot water pipe and different kind of pipes in the roof. So installation with the aluminum cladding, as I mentioned, the roof pipeline must have the aluminum cladding along with the insulation. For the normal pipeline, we can provide the anchor bolt from the slab. Then will be a threaded drop rod will be there. After that, we have the pipe GA clamp. So it's like a split clamp. Also, we can provide split clamp. We can provide here. This is for the cold water and the hot water supply pipe. And the next one, like you see in the tanks, for example, inside the tank. So how the arrangement will be there? So the supply line will come from outside. We have the isolation valve. Then we have the float valve which is touching the water level. So based on the water level arrangement, it can set up the incoming line. And coming to the pump connection, we have the water from water tank, the line is coming, and from here first isolation valve will be there, then the strainer will be there, then the thermometer and the pressure gauge will be there, then we have the flexible connection, then the pump will be there, then again we have the flexible connection. So these two flexible connection to avoid the transfer of vibration to the system. Then we have the discharge side also, we have the pressure gauge. Again we have the non-return valve or check valve to avoid the water coming back to the pump. So then finally we have the isolation valve. We have to make sure that the end point and starting point we have the isolation valve. So normally what happens, this full setup we call as a skid. So this full setup is coming from the manufacturer, and some of the manufacturer don't provide the flexible connector inside at this level. So we provide normally the flexible connector to outside, flexible connector here and here will provide. Sometime it will come like a full skid including the flexible connector and the strainer. So that is perfect. If you are not getting like a full package, then you have to provide something like a flexible connector outside, some flexible connector outside like this. Okay, so this is important. So I believe you are now very clear about how the installation of a water supply system is done for the high-rise building with the different pipelines and different accessories. So thank you for watching the video. We will meet again with another interesting topic. Thank you.